Okay guys, we're going to go into part 2 of our angle relationships. So some new terms we're going to talk about are transversal, corresponding angles, alternate exterior angles, and alternate interior angles. We're going to talk about what those 4 things mean and how we use them. Okay, so we're going to start with the diagram that you see on the screen. We have 2 blue lines, and those are going to be parallel. And sometimes you'll see a symbol that looks like this, like a little triangle or arrow facing in a certain direction. That's terrible. And that's to show you that those 2 lines are parallel to each other. You should know that parallel lines will never intersect. They're always the same distance apart. And then we have this red line here, which cuts through. So this red line that cuts through is called the transversal. So we're going to name some of these lines. So we're going to call this first blue line M, the second blue line N. So M and N are parallel to each other. And then we have the transversal, which we'll call P. Okay, so some symbols that you're going to see to indicate that M and N are parallel, besides the arrows that I already showed you, might also be something like this. M is parallel to N. Okay, so this symbol right here it looks like 2 parallel lines. That means parallel. So another thing I just want to draw your attention to is the fact that this makes, hold on a second. So what happens here is when you have this transversal that cuts through the parallel lines, it creates 4 angles. So you'll see the 4 angles here and 4 more angles here. And they have a relationship between those 2, what I'm going to call angle clusters. So this is an angle cluster. And this is also another angle cluster. So a few other things I want to talk about before we get into what the angles are is I have highlighted here angles 1 and 2 and 7 and 8. Okay, and those 4 angles are called exterior angles because they are on the outside of the parallel lines. And then we have what we call, so angles 5 and 6 and 4 and 3 are what we call interior angles because they're on the inside of the parallel lines. Okay, so I just want to refresh your memory on a couple of things that we know. We know vertical angles are equal. So we know angle 1 and angle 3 are equal. We know angle 2 and angle 4 are equal because they're vertical. We also know that angle 7 and angle 5 are equal. And we know that angle 6 and angle 8 are equal because they're vertical. Okay, so I just want to list here angle 1 equals angle 3, angle 4 equals angle 2, angle 5 equals angle 7, angle 6 equals angle 8, and these are all vertical angles. So something else that we should know is that angle 1 plus angle 2 equals 180 degrees because those are supplementary. So we know that angle 1 plus angle 2 equals 180. We also know that angle 4 plus angle 3 equals 180. So angle 4 plus angle 3. So I'm not going to go through all of the supplementary angles, but don't forget that we also have angles 1 and angle 4 are supplementary, which means they add up to 180. And then we also have angles, come on, let's use blue. So angles 2 and angle 3 together are supplementary. So we're not going to go through both angle clusters. We're just kind of reviewing what we know, and we're going to apply that. Okay, so now we're going to talk about how the two angle clusters are connected. So what I'm going to do here is I'm going to take the angle cluster 1, 2, 3, 4, and I'm going to drag it down on top of the angle cluster 4, 5, 6, 7. And you should notice that the sets of angle clusters are pretty exact. Now, bear with my weird copy and paste editing here because it's not really working out for me right now. I'm not sure why. Worked when I tried it before. Okay, so that angle cluster, if I take it and I bring it down, it's exactly the same because that transversal is cutting through the parallel lines at the same angle. So it's going to create 4 congruent angles. So what happens here is that this angle cluster, let me move that one out of the way, and this angle cluster down here are congruent. But they have to be in the corresponding spots. So the angle that's in the same spot is congruent. And you see that when I took this angle cluster and I brought it down. Okay, it fits exactly on top of each other. So what that means is angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. So angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. And we have angle 4 is congruent to angle 8. And angle 3 is congruent to angle 7. So angle 3 equals angle 7. And angle 4 equals angle 8. And those reasons we call corresponding because they are in the same position in another figure with the parallel line. So this is called corresponding. So that's called corresponding. Now we're going to use that information with what we just reviewed to come up with some other angles that are congruent. Okay, so what I did on this screen was I took 2 of our previous screens and I shrunk them and I put them together. So here on the left, you're going to see the diagram we had and the angles that we determined were equal because of vertical angles. And on the right is the diagram from the previous screen where we talked about which angles were congruent because they were corresponding. So my corresponding got cut off here, so let me write that in. So on the left you have the vertical angles, on the right you have the corresponding angles. So here are the angles and they're color coded in each diagram which ones are equal. So if we have, so we're going to do something called a, okay, I just won a car apparently, and that's who was on the phone. So we have, I forgot where I was. So we're going to do something called a geometric proof. So we're going to split our paper. Now my paper is going to have to go onto 2 screens. So we're just going to split our paper in 2 columns. Okay, so we have statements, and then we have kind of like our reasoning. And when you get into geometry as a freshman or sophomore, you're going to do a lot more proofs. But this is just for us to keep our thoughts organized. So what we have is, if we know that angle 1, if we know angle 1 and angle 3 are equal because they're vertical, and then on the right we know angle 1 and angle 5 are equal, then angle 5 and angle 3 must be equal, okay? So we have angle 5 must be equal to angle 3, okay? And our reason is that angle 5 is equal to angle 1 because they're corresponding. And then we also know that angle 1 equals angle 3 because of vertical angles. So therefore, angle 5 is equal to angle 3. And that's called, so angle 5 is equal to angle 3, and I wrote that backwards from how I said it. And we call that alternate interior angles. Okay, so alternate interior angles are equal. So if we know that angles 5 and 3, okay, they're on alternate sides of the transversal and they're equal because of the reasons we just talked about, then 4 and 6, I'm thinking, are also equal. So let's see if we can prove that. So we're going to look here and see how we can prove that. So I know that angle 4 and 2 are equal because they're vertical. So angle 4 equals angle 2 because they're vertical. And I can tell on the other side, let's see, that angle 4, so we said angle 4 and 2 on this side. So 2 and 6 we can see are equal because they're corresponding. So angle 2 equals angle 6 because of corresponding angles. So therefore, angle 4 is equal to angle 6 because when you put vertical and corresponding angles together, that makes those alternate interior angles. So we've proved that 4 and 6 are equal and 5 and 3 are equal. So let me get that up on a diagram. Give me a second. Okay, so here we have the two sets of alternate interior angles that we found. We found angles 4 and 6. 4 and 6 were equal, and 5 and 3 are equal. So I drew a little diagram, I color-coded them, and I put a note that these are alternate interior angles and that they are equal to each other. Okay, so let's talk about some other angles that could be equal. So when I look at this vertical side, I'm going to maybe start down here in this angle cluster. So I'm going to just say, let's take a look at the fact that 5 and 7 are equal. So angle 5 equals angle 7. We know that because they're vertical. And what else do we know about either one of those angles? Okay, so I know that angle 5 and angle 1 are corresponding. So I'm going to write that down. So angle 5 equals angle 1 because they're corresponding. So I can deduct from this that if angle 5 equals angle 7, but angle 5 also equals angle 1. If these are all equal, then angle 7 has to be the same as angle 1. So angle 7 is equal to angle 1. And when we combine that vertical and corresponding proof together with these angles, which we just proved angle 7 equals angle 1, those are on alternate sides of the transversal, but they're exterior angles. So, as you guessed, these are called alternate exterior angles. Okay? Alternate exterior angles. So if that worked with angle 1 and angle 7, I'm going to assume that it's also going to work for angle 2 and angle 8, because those are alternate exterior angles as well. So let's just do a quick proof of that. So we know that angle 8 and angle 6 are vertical, so they're equal. So angle 8, so we think angle 8 equals angle 2, and we think that it's alternate exterior angles. Okay, and so we just said angle 8 equals angle 6 because they're vertical. And we can also prove that, let's see, what else do we know about angle 8? We know 8 equals 6, and we know 6 equals 2. So we know angle 6 equals angle 2 because those are corresponding. So again, just like before, we can move to say that angle, if 8 equals 6 and 6 is the same as 2, then they're all equal, so 8 equals 2. And that reason is alternate exterior angles. Okay? Okay, so we just proved 2 more angles in this diagram are congruent. So we said angle 8 and angle 2 are congruent because they're alternate exterior. And we also proved that angle 1 and angle 7 are congruent because they're all, so these are alternate exterior angles, and they are equal. And before we go, I just want you to be aware of other ways that these images can look. Okay, so think about how any of these could be twisted, flipped. Okay, so when you see a diagram, don't get confused. Okay, turn it so that it's easier for you to look at. Because as long as the lines are parallel and they're cut by a third line, all those rules are going to apply. Corresponding alternate interior and alternate exterior angles are all going to be equal.